ini betul lewat.
Nah, alin આવ્યો છે.
Kali
Good evening, everyone. I think all of you can see the screen now. Can you hear me, all of you? Am I clear? Am I loud and clear? Okay. Right, very good. So we were solving this question, and actually I asked you to solve two questions for homework from the book, right? It's fine if you couldn't do it, right? I will show you how to solve this question, right? And hopefully that will make it easier for you to then do it, right? So if you have not completed these two questions, please don't worry, right? Okay, right? So sure. So we will definitely discuss your queries regarding these two questions, 3.7 and 3.9. Okay, but not today, tomorrow. Let me show you once how to solve one complete problem by Kirchhoff's laws. Okay, and then you try it again, and if you still cannot do it, we'll definitely do it tomorrow. All right? Okay. Okay, then so here is the question, right? So let's begin. So like I was saying yesterday, that if you want to find current through each resistor, we have to find we have to follow those steps, right? So step one is that first of all you should decide on current everywhere. So I took I1 here, right? And if I take I2 here, as you can see, I've already marked it, right? Just before the connection, just before the connection stopped working. So this is what is I2. So now what should be here? See, don't give answer according to what you have written. Give answer according to what I have written. Okay, look at this. I1 coming in, I2 going out. What do you think is in the diagonal? Come on, people, what do you think is in the diagonal? Okay, Avinash, that is right. Yes, everyone, I've got all correct answers. No, Lakshman, it won't be I2. It will be I1 minus I2, right? It will be I1 minus I2. Okay, this current here will be I1 minus I2, right? That is because I1 is coming in, I2 is going out. So if you want to write how much current is going out here, then it, by Kirchhoff's first rule, it will be I2 minus I1, right? Total incoming current should be I1 minus I2. Total incoming current should be equal to total outgoing current, right? Okay, for those who might still be having some confusion, this is how you could do it. See how much is incoming, I1 is incoming, that should be equal to outgoing. I hope that is absolutely clear. Now if you solve it, you will get I1 minus I2, right? So whenever you get confused, you do it like this, right? Everyone, ક્યારેક તમને પણ થશે, બધાને થાય, કોકવાર મને કન્ફ્યુઝન થાય, તો પછી આવું વ્યવસ્થિત કરી લેવાનું. Okay, now let's take loops. So I said we'll take ACDA. So let's take ACDA. So first of all, we go from A to C, right? So we go from A to C. So plus 4 volt for battery, right? Then we are going against the current or opposite to current. So plus 20 into I1 minus I2. Okay. Now we are going from C to D. Okay. So minus 4I2 for the resistor. Okay. And plus 2 volt for the battery. Right. Okay. Now we are going from D to A. So D to A, once again we are going in direction of current. So minus 2I2. And now we have come back to A. So we should write equal to 0. Alright. Okay. So this is how you get the equation. Again repeat. Plus 4 for the battery. We are going from A to C. Then plus 20 into I1 minus I2 for this resistor. Number 5 resistor. Then for resistor number 3 minus 4I2. Then for this battery 2 volt battery plus 2, and then we go from D to A. So minus 2I2 for this resistor. Okay, so that's how you get this equation. Let's simplify it first before we go to the second loop. Okay, before we go to the second loop, let's simplify this. So we have got 4 plus 20 I1. મને બહુ અઘરું મેથ્સ નથી આવડતું હો, એટલે હું તમારી જેમ ડાયરેક્ટ નહીં કરું કંઈ. So we get 6 is equal to, I'm putting all current terms on right side. Okay, so this is what I get. Right, હવે આમાંથી બધામાંથી 2 કટ થાય છે તો કરી નાખીએ. 3 is equal to 13I2 minus 10I1. Let's call this equation 1. Okay. હવે સેકન્ડ લૂપ કયું નક્કી કર્યું હતું? લૂપ ABCA એ જ હતું ને? હા, ABCA. Okay, now it's time for loop ABCA. કાંઈ કામ કરીએ, એક કામ કરીએ, ABCA નથી કરવું, ACBA કરો. Why? You know why? Because AC part is same. તો આપણે એ બેઠું બેઠું લખ નાખી, ફટાફટ થઈ જાય. So plus 4 plus 20 I1 minus I2. I hope you understood what I did here, right? Okay, આ પ્લસ નો લખો તો ચાલે હો, આ તો ખાલી એમ જ, right? Okay, now C to B. Now we are going from C, we are going on the loop ACBA. So if we go from C to B, right? C to B, then that depends on number of currents, right, Avinash? So for C to D, 16I1 minus 8. 16I1 minus 8. Okay, I hope that is clear. આ ડાયાગ્રામ ઉપર નીચે કરવો પડશે ને, બહુ તકલીફ પડવાની છે. 16I1 minus 8. Now we have reached B. Now we are going from B to A. Right? If you go from B to A plus 8I1, I don't think anyone has any problem with that. So હવે આ બધું સિમ્પ્લિફાય કરી નાખીએ તો 4 plus 20I1 minus 20I2 plus 24I1 minus 8 is equal to 0. So finally 4 minus 8 એટલે 4 right side જવા દો, 4. Now what do we have on left side? 44I1 minus 20I2, right? And I'm sure all of you can see that we can cancel everything with a 4 here. We can cut a 4 out of everything, and we get this equation. બરાબર ને? Okay, so we have got these equations now, 2 equations. Now we have to solve them. અચ્છા, એક સાથે લખી નાખીએ તો easy પડે, બરાબર? આની બાજુમાં હું લખી નાખું છું minus 10I1 plus 13I2 is equal to 3. Okay, so this is the first equation. I just copied it here. Okay, now we have to solve. clearly this calls for elimination. બરાબર ને? Elimination. So first of all, we are going to multiply this second equation with 13 and this equation with 5. Right? આ બધી પ્રોસેસ તમારે નો દેખાડો પેપરમાં ચાલે, આટલું લાંબુ તો કર્યું, હવે હજી શું કરવાનું, બરાબર ને? So this is going to be 13 11 143 I1 minus 65 I2 is equal to 13. Okay, અને આ લખી નાખો તો શું થાય, minus 50 I1 plus 65 I2 is equal to 50. Yes, Chaitya, you are right. Perfect. Right? Two unknowns, so two loops must be there. Right? So it solve thase ne, barabar? Okay. So now add. I'm adding, okay, because that will cancel this. So 143 minus this is what? 93 I1 is equal to, this is 28. Barabar ne? Okay. So finally I1 is equal to 28 by 93 ampere. સેનાથી divide નહીં થાય. Okay, leave it like that. At the most, if you want, you could use a calculator and do it. જેવું હું અત્યારે કરું છું, 28 by 93. Okay, 0.301 એવું આવે છે. Understood? હજી સમ પૂરો નથી હો, હજી તો ઘણું કરવાનું છે. Next, I2. So I'm going to put value in equation 2. I'm going to put value in equation 2. 11 into, હવે ડેસિમલ માં કરી જ નાખ્યું છે તો એમ જ રાખો, easy પડશે હવે. Right? So 5I2 is equal to, શું થાય, 11 into 0.301 એટલે કેટલું થશે, 3.3, બરાબર ને, minus 1. Therefore 5I2 is equal to 2.3. Therefore I2 is equal to 0.4, પછી આવશે 30 એટલે 6. Nearly this much. Okay, એક ડિજિટ હું ખાઈ ગયો, પણ એનાથી કઈ બહુ ફરક પડવાનો નથી. Right? Okay. How many of you got this already without my help? I mean, before even I tried. How many of you got this? Very good, people. Very good. Okay, well done. એટલે આમ છે ને, બહુ ચોખ્ખું કહું છું, કિર્ચોફ લો ના સમ્સ છે ને અઘરા ન હોય, પણ આ લાંબુ જોવો તમે કેટલી વાર લાગે અને બહુ ધ્યાન રાખવું પડે ને. there is so much calculation, right? એક જગ્યાએ મિસ્ટેક કરો, મારા જેવાને તો એવું જ થાય, એક જગ્યાએ મિસ્ટેક કરીએ ને એટલે પછી બધી મહેનત પાણીમાં. Okay, so this is how you do it. Now what to do? Let's read the question. Find current in each resistor. ચલો 1 નો આન્સર આવી ગયો. Current for resistor 1 થઈ ગયું ને, I1. Okay, for 4 also done. Okay, but for 5 we have to do it separately, right? For R5 current is I1 minus I2. That is how much? What is I1? I1 to 0.30 and 0.46. So 0.30 minus 0.46. So that is minus 0.16. Again, I hope you still remember what is meaning of this minus sign, right? So the current you can say is 0.16 ampere from what to what? From A to C. C to A. The correct answer will be 0.16 ampere from A to C. Okay. Yes, Chaitya, to check that you can put it back and see if equation is satisfied. Okay, right? That's a possible way. રમ્યક કે છે આની શોર્ટ ટ્રીક આપો. રમ્યક મારી પાસે કિર્ચોફ લો માટે કોઈ શોર્ટકટ નથી અનફોર્ચ્યુનેટલી, બરાબર. પણ આવો સમ હોય તો હું આવી રીતે નો કરું, મેં તમને પહેલા કીધું હતું, પણ એની મેથડ છે આગળ આવશે આ ચેપ્ટરમાં, બરાબર. ઓકે, this question was only there, I only gave it to you so you can practice Kirchhoff law, બાકી કઈ નહીં, બરાબર ને. આ સમ આવી રીતે નો જ કરાય, ગાંડા થઈ જાય. ઓકે, so that other method will come later in the chapter, બરાબર. એટલે ત્યારે પછી આવડી જશે. પણ આનો આમ કોઈ શોર્ટકટ નથી, જો પહેલા જ કહી દઉં છું. લેટ મી ટેલ યુ ધેટ, તમે ગમે એ કરો, આનો કોઈ શોર્ટકટ નથી, બરાબર. બીજી મેથડ હોય પણ એમાંય તે કેલ્ક્યુલેશન તો કરવું પડે, બરાબર. એવું નહીં કે તમે સાવ એમને એમ કરો. આ ટાઈપના ક્વેશ્ચન આવે નીટમાં, પણ જનરલી બહુ લાંબા ન હોય, કંઈક એમાં ટ્રીક વાળા હોય, બરાબર. JEE માં આવે છે કોઈક વાર એકદમ લાંબુ હોય ત્યારે એવું નીકળે, પણ એ રેરલી, બરાબર. ઓકે, આ તો હજી કઈ નથી. હાઉ મેની ઓફ યુ હેવ ટ્રાઈડ એક્ઝામ્પલ 3.7? હાઉ મેની ઓફ યુ હેવ ટ્રાઈડ ધીસ? એ બહુ ખતરનાક ક્વેશ્ચન છે, બહુ જ લાંબો છે. હેવ યુ ટ્રાઈડ ઇટ? બહુ લાંબો છે ને. વ્રજ કે છે 3 પેજ ઓનલી. No problem, Vishwa. It is tough because it's very long. So somewhere you might have made calculation mistake. Then you'll have to do everything again, right? It's very tough in that way. Yes, correct, Darshi. It takes lot of calculation. There are 3 equations to be solved. Correct? There are 3 equations. Yeah. So Kia, that means you got different answer, right? That means you got wrong answer. So you'll have to do it again. Yes, agreed, Himani. Yeah. Okay, એટલે જ તો મેં તમને પૂછ્યું. Fine, let's solve this. Come on. હજી આ બાકી છે. Find terminal voltage. Okay, what's the formula of terminal voltage? Everyone, what's the formula of terminal voltage? What's the formula of terminal voltage? ક્યાં જતા રહ્યા? Do you all remember? Yes, epsilon minus IR or epsilon plus IR depending on situation. Correct? Depending on situation, based on how current is flowing. હું તો એ જ ભૂલી ગયો, શું કરું છું? કઈ નહીં હો. I'm feeling very stupid. Internal resistance તો ક્યાં મેં આપ્યું જ છે. I'm so sorry. So that's why V will be equal to epsilon, બરાબર ને? I hope you understood that, because internal resistance is not there, so V is equal to epsilon. કઈ મતલબ જ નથી ફાઇન્ડ કરવાનો. Thank you, Purvendra, for bringing it to my notice. Right? Everyone, I hope it is clear what I said. Okay, chalo, વાંધો નહીં. Right. Fine. So this is how you solve questions related to Kirchhoff laws. Okay. Steps બધા ફોલો કરવાના. 1 2 3 4 જે લખાવ્યા હતા એ, બરાબર. અને જો આમાં સૌથી સારી વાત શું છે ખબર છે? મેથડ ઇઝ ઓલવેઝ સેમ ઇન ઓલ questions of Kirchhoff laws. Method is always same. કંઈ બહુ બીજું એવું ન વિચારવું પડે કે આમાં શું કરવાનું. You just have to put currents everywhere, I1 I2 I3 જે કંઈ આવતા હોય, અને પછી સોલ્વ કરવાનું હોય, એવું જ હોય, રાઈટ? but calculation is tricky, as you can see. It's very long sometimes. Fine. તો હવે આ બે ટ્રાય કરજો. ઓકે, પછી નો આવડે તો આપણે કાલ કરશું, બરાબર ને? Okay, now let's go to the next topic. Right, let's go to the next topic. Okay, so now we are going to learn about cells in series and parallel. અત્યાર સુધી resistances in series and parallel હતું ને, હવે શું આવશે? cells in series and parallel, બરાબર? હવે એવું શીખવાનું. Okay, so let's start with that. First of all, let's start with series. સાવ easy છે, હા, સાવ એટલે સાવ easy, બરાબર? એકદમ ઇન્ટ્યુટિવ છે. ઘણા બધાને તો એમ જ લાગશે કે આટલું બધું આમાં કંઈ કરવા જેવું નથી. So cells in series. Okay, so it has two parts. It has two parts. First part, helping. Okay, cells in series and helping, that is what? Let's talk about that. So પહેલા diagram draw કરો. Suppose that there are two cells and they are in series, બરાબર? So આ cell 1 with epsilon 1 and internal resistance R1. Okay, I hope that is clear. And what is meaning of helping? Helping means the second cell is also such that it will make current flow in the same direction. એને helping કહેવાય. Okay, something like that. Right? Understood what I've drawn? There are two cells, right? But they are such that they will make current flow or try to make current flow in same direction. So that's why that's called helping. Right? Understood this word? Have a look. If suppose this is one circuit and this is external resistor. Okay, if this is external resistor, so first look at only this. First look at first cell, ignore second. Okay, ignore this right now. Okay, just look at first. So then that will try to make current flow in this manner. Agreed? Right? Now if you ignore first one and just look at second one, then that will also try to make current flow in the same direction. Correct? So that's why these two cells are helping each other. Clear? કેયા ને સમજાઈ ગયું? બીજા લોકોનું શું? Everyone, have you understood why they are helping? Because they are trying to make current flow in same direction. Trying to make current flow in same direction. Okay, right? So now let's use Kirchhoff rule over here in this loop. Okay, right? Let's use Kirchhoff rule. Okay, by Kirchhoff's first rule or Kirchhoff's voltage law, KVL. અરે ઓપોઝિટ ડાયરેક્શન પછી આવશે એટલે તો બે પાર્ટ કરવાના છે, એ હેલ્પિંગ ને પછી બી બીજું. ઓકે, so by KVL and we are taking loop anti-clockwise. Okay, by KVL and using anti-clockwise. All right, by KVL and there is only one loop એટલે બહુ ટેન્શન લેવાની જરૂર નહીં and we are going like this anti clockwise. તો છે ને અહીંથી ચાલુ કરો બરાબર. તો સૌથી પહેલા શું આવશે માઇનસ IR1 પ્લસ એપ્સિલોન 1 આ ફર્સ્ટ બેટરીનું થઈ ગયું. પછી માઇનસ IR2 પ્લસ એપ્સિલોન 2 આ સેકન્ડ બેટરીનું થઈ ગયું. ઓકે દેન એક્સટર્નલ રેઝિસ્ટર હવે આનો વારો આવ્યો. ઓકે so there also of course I'm sure you realize current flows like this only, right? so શું થશે આ minus I capital R is equal to 0 પાછા આવી ગયા ને. okay so finally do you get જો તો વચ્ચેના સ્ટેપ્સ તમારે કરવાના હો, વચ્ચેના સ્ટેપ્સ તમારે કરવાના છે. આવું આવે છે જો તો આવું આવે. okay now let's put or let's just write this in a bracket એટલે બરાબર દેખાય. okay so now we will draw equivalent circuit. okay now we will draw equivalent circuit. અચ્છા એક વસ્તુ કહું, હવે એક બે સ્ટેપ્સ લખાવું છું ને એ ખાલી તમારી ક્લેરિટી માટે છે. તમે કદાચ નો લખો ને ડાયરેક્ટ લખ નાખો તો ચાલશે, મારા ખ્યાલથી બુકમાં તો સીધું જ લખ નાખ્યું છે, પણ હું તો એ કરું છું. તમારે એક્ઝામમાં લખવું ન લખવું તમારી ઉપર. so what have I drawn here? This is equivalent circuit, okay, such that this battery has epsilon equivalent and R equivalent, okay, and current flowing should be same. so આમાં તો I આવી રીતે જ આવે. I don't think anyone has any doubt about it. એક જ બેટરી છે ને, easy, right? okay so now we will compare which equation 1 and 2 we will compare, right? okay so by comparing equation 1 and 2 એટલે આમાં હું જે ઓપ્શનલ કહું છું ને એ આ છે, આ જે બ્લુમાં માર્ક કરું ને એટલું ઓપ્શનલ. ઓકે સમજી ગયા? આવું આટલું ડ્રો ન કરો તોય ચાલશે. ઓકે લેટ્સ કન્ટિન્યુ. ઇફ વી કમ્પેર ક્લિયરલી જ્યાં એપ્સિલોન ઇક્વિવેલન્ટ છે ને ત્યાં એપ્સિલોન 1 પ્લસ એપ્સિલોન 2 છે, બરાબર? અને જ્યાં આર ઇક્વિવેલન્ટ છે ને ત્યાં R1 પ્લસ R2 છે. યસ ઓર નો? ક્લિયર એવરીવન? okay right so this is it. તો થઈ ગયું ને, જો એકદમ સિમ્પલ આઈડિયા. look at this, these two batteries were helping each other, correct? they are in series and they are helping each other. તો total EMF શું થઈ ગયું? epsilon 1 plus epsilon 2. કેમ? હેલ્પ કરે છે તો એડ થાય ને, સિમ્પલ. ઓકે બટ when that happens equivalent resistance તો એ series માટે R1 R2 હશે ને, R1 plus R2 sorry, right? this and this are in series, correct? તો series માં શું આવે? R1 plus R2. simple. તો આ શોર્ટકટ એ સમજ પડી ગઈ, how to do it directly without having to derive it every time. કોણ દર વખતે એટલું લખવા બેસે ને આવું ડિરાઈવ કરે? એકદમ ઈઝી જ છે. ઓકે રાઈટ. એક્ઝામમાં પૂછે તો સીધું આવું ન લખ નાખતા પ્રૂફ. ધીસ ઇઝ નોટ પ્રૂફ, ધીસ ઇઝ ઇન્ટ્યુશન એન્ડ ધીસ ઇઝ પ્રૂફ. બરાબર ને? આખું પ્રૂફ આપણે લખ્યું, બરાબર? એક્ઝામમાં પૂછે છે આવું, ડિરાઈવ ઇક્વિવેલન્ટ EMF એન્ડ ઇક્વિવેલન્ટ રેઝિસ્ટન્સ. ઓકે 2 માર્કમાં પૂછે, આરામથી લખાઈ જાય. Okay, now opposing condition. ચલો ફટાફટ હવે opposing condition. એક હેલ્પિંગ હતું ને હવે opposing. ઓકે, તો એમાં કેવો ડાયાગ્રામ આવશે? કઈ નહીં, ઊંધું ફેરવી નાખશું એકને. So this is one battery, epsilon 1 comma r1, and now suppose this is another battery. અને એવું જરૂરી નથી કે આ નેગેટિવ ની સાઈડ લખો, ગમે ત્યાં કરો, પણ જનરલી લોકો એવું કરતા હોય એટલે આમ. Okay, it does not make any difference. Remember, it does not make any difference whether you draw that internal resistance on left side or right side. Okay, હવે આવો. You can clearly see that these batteries are opposing. અચ્છા, આ બે સિરીઝ માં છે, પેલા ઈ તો કહો મને. Are these batteries in series really? How do you know? ખબર કેવી રીતે પડે સિરીઝ માં છે? એની કઈ મેથડ છે? How do you know that these are in series? Yes, between these two batteries there is no splitting of wire. જો આ બે વચ્ચે ક્યાંય split થયો wire, that means they are in series. બરાબર. Yes, Dhaval, you are right. Okay, so now let's derive it. Again we will use Kirchhoff voltage law, and we will go anti-clockwise in the loop. Okay, and suppose the current is I. एक मिनट, sorry, एक मिनट. Okay, let epsilon 1 be greater than epsilon 2. આવું assume કરો અત્યારે. Right, let epsilon 1 be greater than epsilon 2. Okay, Arshad, no, that's not required. What you said is not required. એના વગર એમને જ છે, right? No branch means series. Okay, so let epsilon 1 greater than epsilon 2, right? So current will flow in this direction. Is that clear? Is that clear? Current will flow in this direction. Clear or not clear? Why? Because this battery wins. I hope you understand that. Right? અચ્છા, intuition થી આન્સર કહો તો આ શું આવશે? Intuition થી કહો તો આન્સર. Very good. It will be epsilon 1 minus epsilon 2. Now this is happening only because of this, right? Please remember that. Okay, આ શું આવશે? Intuition, come on. Very good, Rutva. Same એટલે શું? It will be R1 plus R2, right? It will be R1 plus R2. Resistance થોડું subtract થાય. Think about it. If two resistors are in series, that's right, Kia, same as first. If two resistors are in series, resistance subtract તો no થાય ને. I hope you understood that. Okay. So let's derive it now. આ તો બરાબર એમને એમ લખી નાખ્યું, હવે derive કરી નાખીએ ને. જો using KVL or Kirchhoff's loop rule. તમારી બુકમાં loop rule લખ્યું હોય તો તમારે એવું લખવું હોય તો વાંધો નહીં. Kirchhoff loop rule, because this is on a loop. Again we are going anti-clockwise. Okay, એટલે આમ, right? So in direction of current, right? તો ફટાફટ લખ નાખો. જો અહીંથી સ્ટાર્ટ કરશો આમ. So minus IR1 plus epsilon 1 minus epsilon 2 minus IR2 minus I capital R equal to 0. અને પછી આને સિમ્પ્લિફાય કરો. બાકીનું એમનેમ છે, આગળ નહીં લખું. I hope you will be able to do it on your own. Okay, આવું આવશે, right? I think that's good enough explanation. So the general rule is as follows. Look at this. Okay, the general rule is as follows. For batteries in series or cells in series, for helping, epsilon equivalent is equal to epsilon 1 plus epsilon 2, whatever that is, right? And for opposing, epsilon equivalent is epsilon 1 plus epsilon 2, whatever, right? And from that you have to subtract, okay? Or you could just write negative for opposing, right? But remember negative for opposite batteries, right? Negative for opposite batteries, but remember that this should turn out to be positive, એટલે modulus મૂકી દેવાનું, બરાબર ને? Everything is visible, right? I have not written anything else. આટલું જ લખ્યું છે. Everything is visible, Soral. Why to let epsilon 1 greater than epsilon 2, Darshi? That was so that we can decide direction of current, right? If instead of this it was epsilon 2 greater than epsilon 1, so current ni direction ઊંધી આવે ને, આમ આવે. Clear? Right? Then here also we will get I is equal to epsilon 2 minus epsilon 1 upon R plus this. Okay. So Rally, you can see it now. I hope you can. So it's important to put modulus, everyone. કારણ કે negative નો આવવું જોઈએ છેલ્લે. Right? It's important to put modulus, right? Okay. And R equivalent is always R1 plus R2 plus R3. This is common sense, right? Series જ છે એટલે કઈ ન આવે. Okay, fine. Now parallel. Parallel is more interesting in my opinion. Cells in parallel. Right. So let's draw a diagram first of all. Y3 is opposing એવું નથી કીધું. 2 હોય 3 હોય 5 હોય તો શું કરવાનું? બરાબર ને રમ્ય? જે ઊંધી હોય એમાં માઇનસ લખવાનું, જે સીધી હોય એમાં પ્લસ લખવાનું. સિમ્પલ. ઓકે. So now let's talk about cells in parallel. Let's say that there is a resistor R, and from that, okay, in that resistor R, two batteries are trying to make current flow. Okay. So let's say this is the first one, and let's say this is the second one. Right now, let's keep both of these in same direction. Then I'll explain what happens if they are not. Okay, so that's what we have, right? So this is R1, sorry, epsilon 1 and R1 internal resistance, epsilon 2 and R2 internal resistance. All right? Okay, diagram is clear? The two batteries are in parallel. Because remember, this is one thing. આખું એક જ છે, એક બોક્સમાં હોય, right? I hope that makes sense. This whole thing is in one box, right? So there are, sorry for such an ugly diagram, like this. Okay, so yeah, so now what we have is right epsilon 2 and r2. Yeah. So now let's say that currents are, so let's say that currents are as follows: I2 here and I1 here. First battery my I1, second my I2. Okay, so how would you write it? You write, let two cells with EMF epsilon 1 and epsilon 2 and internal resistances R1 and R2 be connected in parallel. Okay, પછી current through these cells is I1 and I2 respectively. Okay, current through these cells is I1 and I2 respectively. Now you know what we'll have to do. We'll have to put points here. I'm actually kicking myself. I've drawn such a small diagram, right? So if we will take points, right? So let's say that જગ્યા જ નથી આમાં હું ક્યાં draw કરું? So that's a lesson for all of you. Draw larger diagrams. A, B, C, D, E, and F. Okay, you can see all the points clearly, or is it too small? Okay, so now we have already mentioned what's the current flowing in first battery, second battery, or second cell, right? Now for resistor, okay, ચાલશે એ કઈ કરવાની જરૂર નથી. અહીંયા ડાયાગ્રામમાં દેખાય ને, do you realize that this current will be I1 plus I2? That same current will be flowing here, right? Okay, right? So you could just write it as follows: current flowing through resistance R is I equal to I1 plus I2. All right, current flowing through resistor R is I equal to I1 plus I2. Okay, now we will use Kirchhoff's rules, okay, the loop rule, to get a relation between these things. So let's start. So first of all, we'll take loop A, B, E, F, A. Okay, so first loop using KVL or Kirchhoff's first rule for second rule for loop A, B, E, F, A. All right. I want all of you to have a look. What is A, B, E, F, A? A, B means going through the first battery, then going to E, F, and A. Right? Okay. So I'm writing an equation for it. મેં તો જોઈ લીધું બરાબર. હું હવે સીધું લખી નાખું. Then you tell me whether you agree with it or not. Okay. Okay, is this clear, people? Did you understand this? Okay, fine, very good. And similarly, હવે બહુ વધારે પડતું લખવાની જરૂર નહીં, right? Similarly for loop, what's the other loop that we'll have to take? A B ની જગ્યાએ C D લખવું પડશે ને, C D E F C. ઓકે, ડાયાગ્રામ જોયા વગર લખું જો ડેરિવેશન. Similarly for loop C D E F C, we'll have minus I2 R2 plus epsilon 2 minus IR is equal to 0. Okay, right? So you know what we are going to do now? We will find value of I1 from this. ના એમ ને, sorry એવું નથી કરું, that will not be the correct way. Now we will draw equivalent circuit. Okay, ના જો કે એનો કઈ મતલબ નથી, આમ જ કરવું જ પડશે. Sorry, I just got a little bit confused. We will have to find what is I1 from here, we will have to find what is I2 from here and put it over here, okay, in this equation. So sorry, I got confused, right? We will find I1 from here and I2 from here. We have done things like this earlier, right? So I'm not going to spend too much time doing it, right? So I1 ની value શું થશે? Epsilon 1, okay, minus IR upon R1. Clear? નીચે લખો, અહીંયા લખવાનું તમારે તો. Okay, using these equations, you લખો, using these equations, I1 is equal to epsilon 1 minus IR upon R1. Oh, sorry, I capital R. And I2 is equal to epsilon 2 minus I capital R upon R2. Okay, right? Okay, so now we will put this, listen to this carefully, now we will put all of this in this equation here, right? Okay, we'll put all of this in that equation, right? And at the same time, listen to this carefully. ચલો વાંધો નહીં, એક સ્ટેપ વધુ લખ નાખીએ, તમને કન્ફ્યુઝન ન થાય, તમને આવડી જવું જોઈએ એક વારમાં તો, right? I don't think you have any problem with this, right? Putting I1 and I2's value, right? And finally, instead of writing I, we are then going to compare it with that equivalent. Okay, પણ પહેલા આને થોડુંક સિમ્પ્લિફાઈ કરવું હોય તો I hope you have no doubts about this. Clear? LCM લીધો ખાલી. So then this can be written I'm so sorry again, we should, I mean this is the right step, but we still have to simplify this so we can find out I. Just strike that out. Okay, math સાચું છે પણ direction સાચી નથી, strike it out. So sorry, that will not help us. Rather we will split I from here, એનાથી જલ્દી થઈ જાય. Okay, we have split the numerator, right? Okay, now we take this I, right? We take these two terms with I on the right hand side. સમજાય છે ને? We take these two terms with I on the right hand side. So over here we will get this. Clear? Okay. Now we will take I common. Now we will take I common. Clear? What have I taken? I've taken I common, and you can see also R is common here in these two, not in third. એટલે એમાં 1. પછી અહીંયા બેમાં R common. Okay? Right? And then the next step is this whole bracket can be divided on this side. Okay, this whole bracket can be divided on this side. So epsilon 1 by R1 plus epsilon 2 by R2 upon, okay, we are out of space on this page, upon 1 plus R into 1 by R1 plus 1 by R2. જો ક્લાસરૂમની દિવાલ ઉપર લખ નાખ્યો, બોર્ડ નાનું પડ્યું તો. Okay, I just divided it over there, right? Now we have to go to the next page, right? I hope you have written it so far. I'm going to change to the next page. All right, so we will take LCM here, right? We will take LCM over here. Okay, in the denominator, right? Please be careful. We will take LCM in the denominator. Yes, R1 R2 will get cancelled when we do that. Okay, next page. So it will give us I is equal to epsilon 1 by R1 plus epsilon 2 by R2 upon. Here you get R1 R2 plus R into R1 plus R2 upon R1 R2. Is this clear? Now I am looking. So this I is now equal to epsilon 1 R2. અહીંયા multiply થાય ને. I hope all of you remember that. એમનેમ રાખો, કઈ વાંધો નહીં, મલ્ટીપ્લાય કરીએ તો એ થઈ જશે. એટલા જ સ્ટેપ્સ થાય છે, એમનેમ ખાલી લખવું જો આવી રીતે. ઓકે, right? So now our plan is, listen to this carefully. Our plan is that we will divide by R1 plus R2. We will divide by R1 plus R2. I'm sure there will be some other method. આ ઘણું લાંબુ થઈ ગયું, કંઈક કેલ્ક્યુલેશન અલગ રીતે કરો તો નાનું થતું હશે. But anyways, we have got so far. હવે બહુ આગળ બાકી નથી. So we divide everything by R1 plus R2. અહીંયા આ કટ થઈ જાય, સમજાય ને? રાઈટ? ઓકે. So based on this, if we will compare, based on this, if we will compare, then we are going to get, ના તો ડાયમેન્શનલી રોંગ આવ્યું. અરે યાર ક્યાં મિસ્ટેક કરી નાખી. સો સોરી અગેન. ન્યુમરેટરમાં રહી ગયું ડિવિઝન. અરે હા, બરાબર બરાબર, સાચું સાચું. That is right. ડિવિઝન રહી ગયું ન્યુમરેટરમાં. ઓકે, ના એ ફોર્મમાં નહીં રહેવા દેવાનું. આ રીતે સિમ્પ્લિફાઈ તો કરવું જ પડે, રાઈટ? So then if you will compare it now with that equivalent, okay, comparing with I is equal to epsilon equivalent upon r plus r equivalent, okay, આ તો આવે જ compare કરવા માટે, right? So from that r equivalent is equal to r1 r2 upon r1 plus r2, correct? Okay, from that r equivalent is equal to r1 r2 upon r1 plus r2, and epsilon equivalent is equal to, હવે LCM લેવાય તો છે ને આ કટ થઈ જશે. So you get epsilon equivalent equal to epsilon 1 r2 plus epsilon 2 r1 upon r1 plus r2. ઓકે, પણ આ ફોર્મમાં એકચ્યુઅલી છે ને યાદ રાખવું ઈઝી નથી. This is very tricky to remember. Easier form of the same thing is this. Easier form of the same thing is this. કારણ કે આ શું છે? What's this bracket? R equivalent, correct? Right? This bracket is R equivalent. તો એને ખાલી ઓલી બાજુ divide કરી દો. I hope you understood what I said here. Right? If you will take LCM, things will be cancelled and you will get this. આ ફોર્મ્યુલા આવશે. પણ આ ફોર્મ્યુલા છે ને યાદ રાખવી ઈઝી નથી, એટલે આ બહુ ઈઝી છે. And in fact, this is more applicable. What if there are 3 cells? Then also this kind of pattern will be applicable. આવું કરી શકાય, right? ના એવું કઈ નથી. આમાં એક તો પાછળના સ્ટેપ્સ દેખાય નહીં ને, થોડુંક મને એ પ્રોબ્લેમ પડે. બોર્ડ જેવું મોટું તો ન હોય કે એક સાથે બધું દેખાય. Anyways, આ તો I will find out. I'll see if there is some other way by which we could do it. Yes, if you write it like this, then this is for any number of cells, okay? Right? If you write it like this, you can do it for any number of cells. All right? જરૂર નહોતી સોરાલી ડિવાઈડ કરવાની, એના વગર થઈ જાત. Never mind, whatever it is, I'll think about it. I'll go through this, right? આના કરતા easy તો possible છે જ. પ્રીવિયસ સ્ટેપમાં જ આવી ગયું હતું એવું કહે છે. ઓકે, ના ડિવાઈડ તો કરવું જ પડે એવું હતું. ડિવાઈડ તો કરવું જ પડે એવું હતું. Okay, fine. We'll talk about it the next time. Okay. અરે આ નહીં, હું શોર્ટર મેથડ મોકલું છું પૂર્વેન્દ્ર, રાઈટ? There will be some easier way out. આટલું લાંબુ ન થાય, right? Okay. I will send that to all of you, right? Goodbye, everyone. We didn't compare before dividing, Arshad, because at that time it was not dimensionally correct. Here, if you look at this equation, Arshad, this is what you're saying, right? See, this is not dimensionally correct. Look at denominator. I mean, correct in the sense it doesn't match dimensionally with this. It doesn't match with this. અહીંયા ખાલી r છે, આ ખાલી r નથી. I hope you understood why we have divided, right? Okay. Yes, we'll have to bring r, right? એના વગર નહીં થાય. ટાઈમ પતી ગયો, ખબર છે. ચલો.